Hi, and welcome to part one of today's lesson. And today's lesson we're going to be talking about inequalities in triangles. So part one we're talking about inequalities in one triangle, and part two we're going to be talking about inequalities when you're comparing different triangles to each other. So when we say inequalities here, we mean that things that are not congruent. We know that things aren't congruent. In previous units, we talked about if we know we have an equilateral triangle, that is, all three sides of a triangle are congruent, that means it's also going to be equiangular. The angles of the triangle are also going to be congruent. We also talked about isosceles triangles, where if you have two sides of a triangle that are congruent, the angles that are opposite them are also going to be congruent. This is related, but it has to do with what happens if they are not congruent, and that's why we have inequalities here. So two theorems that we're going to start with down here. The largest side of a triangle is opposite the largest angle. So assuming that your sides and angles in a triangle are not congruent, the largest side is always going to be opposite the largest angle. And the converse is also true. The largest angle in a triangle is opposite the largest side. So when we say opposite, we mean the one that the angle is not touching, the one that's across from the triangle. So a couple examples here which I think will help make a little more sense. The triangle over here on the left-hand side, we know the measures of the angles, and they are 40 degrees, 60 degrees, and 80 degrees. So the smallest angle in this triangle measures 40 degrees. That means that the side that's opposite this angle, this side over here, must be the smallest side in the triangle. The next angle is 60 degrees, so the side that it's opposite is going to be the middle side. And the biggest angle in this triangle is 80 degrees, and that means that's going to be opposite the biggest side in this triangle. I don't actually know how long these sides are, but I can put them in order, and I know which one's largest and which one's smallest. The triangle over here on the right-hand side, we know the lengths of the sides. This triangle is not drawn to scale. So our smallest side here is 8. So the side that measures 8 is going to be opposite the smallest angle in the triangle. The next side is 11, which is this side over here on the right. So this side is going to be opposite the middle angle. And finally, the largest side, the longest side here is 15. And this side must be opposite the biggest angle in that triangle. And again, that doesn't mean we can figure out how large the angles are, or the measures of the angles, but it does mean that we can put them in order. So a couple examples to see how this works. Example number 1 uses triangle ABC. So we're given that the measure of angle A is 58 degrees, and the measure of angle B is 60 degrees. So we can use a triangle angle sum theorem that says the measures of the interior angles of a triangle add up to 180 degrees. That means that the measure of angle C must measure 62 degrees. So in this triangle, the angles are not congruent. That means that the sides are not going to be congruent either. So the first question asks for the longest side. Well, the longest side must be opposite the largest angle. The largest angle here is angle C. Angle C is opposite AB, that's the side it's not touching, so that means the longest side in this triangle must be line segment AB. The shortest side in this triangle must be opposite the smallest angle. So in this triangle, angle A measures 58 degrees, and that's the smallest angle. So the side that's opposite that angle, line segment BC, must be the shortest side in that triangle. So that's the first one. Given the angles, can you figure out the sides? Next one here, for example number 2, we have triangle XYZ, and we know the lengths of the sides. So the distance between X and Y is 8, the distance between Y and Z is 10, and the distance between X and Z is 12. So in this case, it asks us to arrange the angles in order from largest to smallest. So the longest side in this triangle is line segment XZ, which measures 12. That means that the angle that's opposite XZ, angle Y, that must be the largest angle. So our first angle is going to be angle Y. Next we have YZ, which measures 10. So the angle that's opposite YZ is going to be angle X. So that must be our next one. And finally, the shortest side in this triangle is XY, which measures 8. So 8 is opposite angle Z, so that must be our last angle. That's going to be our smallest angle. So our biggest one was Y, our next one was X, and finally our largest angle, our smallest angle in this triangle must be angle Z. So it's not too bad when you have a triangle and you know the angles to put the sides in order, or if you know the sides to put the angles in order. So our last one that we're going to do here before I give you a chance to practice is going to be what happens when you have more than one triangle. Now, here's where you don't want to get lost, because even though there's more than one triangle in this picture, the key to solving this problem is to only look at one triangle at a time. So I'm going to start with looking at just this triangle over here on the left, triangle SPQ, this one over here. So I'm given the measure of this angle here is 75 degrees, and the measure of this angle over here is 70 degrees. So we use triangle angle sum theorem again, and we can figure out the measure of angle P must be 35 degrees. So the measure of angle P is 35 degrees. Now for this triangle only, for triangle PQS, this one over here only, we should put the sides in order from smallest to largest. And I did write largest to smallest by mistake on your papers, and you can see I've crossed that out here. The inequalities that I've written are less than, so it should have said smallest to largest. So if you haven't already, go ahead and change that. It should say smallest to largest. So in triangle PQS, the smallest side is going to be opposite the smallest angle. So the smallest angle in this triangle measures 35 degrees, and that's going to be opposite SQ. So the distance between S and Q is going to be the smallest distance. Next is 70 degrees, and that's going to be opposite this line segment here, SP. And finally, the largest angle in this triangle is 75 degrees, and that's going to be opposite PQ over here. So that's going to be the largest side in this triangle. This is a good point in the video. Go ahead and pause the video and go ahead and figure out the measure of this angle here and put the sides of triangle QRS in order on your own. Pause the video and we'll check your answer when you get back. So hopefully you were able to figure out that the measure of angle SQR, this angle here, is going to be 60 degrees. And then we can look at the three sides of this triangle. So from smallest to largest, you should have gotten QR, SR, SQ. Now, finally, after you treat each triangle separately, the last thing you're going to do is you're going to compare them to each other. The trick here is going to be the fact that these two triangles, even though they're two separate triangles and we treated them separately when we're ordering them, they do share a side, line segment SQ, this one here. And we know by the reflexive property, SQ is congruent to itself. If you look at these inequalities, SQ is part of this triangle and part of this triangle, so it's going to be part of both of these inequalities. So for triangle PQS, it's the shortest side. For triangle QRS, it's going to be the longest side. That means we can put these 5 line segments in order from smallest to largest all together. So we can put our shared side, SQ, in the center here. And that is going to be our center. Then in PQS, these other two sides are larger than SQ. So that means on this side we have SP and PQ. And in triangle QRS, we have these two sides which are shorter than SQ. So these are going to be less than SQ. So we have QR and we have SR here. And so we've managed to combine these two different inequality statements together to make one big inequality statement. Now, the ones that are in your homework in the textbook are a little bit more difficult than this, but honestly, the ones that you will see on the quiz and the test are pretty much about the same difficulty level as this one. So you're not going to see anything more difficult than this as far as comparing two triangles to each other, the ones that are stuck together like this go. Go ahead and pause the video here. On the next page, you're going to see 2 examples. Go ahead and do those on your own. Pause the video and we'll check your answers when you get back. So for these 2 examples, hopefully you were able to get number 1, list the sides in order from shortest to longest. So hopefully you got line segment XY, line segment ZY, and line segment XZ in order from shortest to longest. Example number 2, list the angles in order from smallest to largest, and hopefully you were able to get this one as well, angle L, angle J, and angle K. And hopefully you managed to get the notation correct as well. All right. Finally, The other thing we're going to talk about today is about what the third side can be in a triangle if you know how big two sides are. So I'm going to go ahead and switch over to this window for a second. And here we have a triangle, and we know that A, the distance between A and C, is going to be 6 centimeters. And B, which is the distance between C and B on this triangle, is 8 centimeters. So these are fixed, and they're not going to change. So the question we're asking is, well, what could the lengths of this third side be, this line segment AB, the C, as it's noted here? Right now, it's 8.75 centimeters. Now, it kind of makes sense that if I make this angle smaller, so this side here is opposite angle C. If I make angle C smaller, then this side here is going to get shorter. Now we're down to 4.52. And we could imagine that side getting smaller and smaller and smaller and smaller and smaller and smaller. And at some point, we can go past it, and it gets larger again. But the question is, how small can it be and still be a triangle? So is there like a limit for how small that third side can be? Again, if we're not changing the other two sides, how small can that third side be? Well, if we make it as small as we possibly can, at this point, where it's 2, the distance between A and B is 2, it's actually not even a triangle anymore. These 3 points are collinear. It's no longer a triangle. It would have to be a little bit bigger in order to be a triangle. So something that's a little bit bigger than 2. On the other hand, if I make that angle bigger and bigger and bigger, that line segment gets longer and longer and longer. And at this point, it's longer than it was when we started. And it can keep getting longer and longer and longer and longer. And the question is there an upper limit for how long that third segment can be? And of course there is, because if I make it big enough, if I make that angle 180 degrees, in fact, I've made it to the point where these 3 points are collinear and they don't make a triangle anymore. So that's interesting. So remember, the two sides that we started with were 6 and 8. And we had to have it larger than 2, so we could get it close to 2, but it couldn't actually be 2. And we could get it almost as big as 14, but not quite. Otherwise, it's not a triangle. And that's actually the main idea behind this part that we're looking at right now. So back on your notes, the second part here, finding possible measurements for the third side in a triangle. We see the third side of a triangle must be bigger than the difference of the two sides and smaller than the sum of the two sides. So say the two sides in a triangle we know are 15 inches and 22 inches. So we know for sure those two sides of a triangle. And the question is, what are the possible lengths of the third side? So we actually start by representing that third side, since we don't know what it is, with x. And we're going to put less than on either side of it. So we have x, and then we have a less than on this side and a less than on this side. It has to be bigger than the difference. So we're going to subtract the two numbers. Now, use some common sense here. We're not going to do 15 minus 22 because we're not going to end up with a negative number. We're going to do 22 minus 15. You're always going to do the bigger number minus the smaller number. So 22 minus 15, and it has to be smaller than the sum. So that's 22 plus 15. And you can go ahead and simplify that. So 22 minus 15 we know is 7, and 22 plus 15 we know is 37. So that third side of the triangle can be anything between 7 inches and 37 inches. It can't actually be 7 inches or anything smaller than 7 inches. It can't actually be 37 inches or anything larger than 37 inches, or else it wouldn't be a triangle. But it can be anything in between those two numbers. So here are a few practice problems. You're given two sides of a triangle, and you need to list the possible lengths of the third side. So we start off with 23 centimeters and 14 centimeters. So we're going to start off by putting an X and putting little less than signs on either side. And then the two sides that we know, we're going to subtract them and we're going to add them. So again, use some common sense. Should it be 23 minus 14 or 14 minus 23? It's always going to be the larger number minus the smaller number. So we're going to do 22 minus 14. And it has to be smaller than the sum, so we're going to do 23 plus 14. Once you have that, you can simplify. So 23 minus 14, we can figure out what that is, and 23 plus 14, we can figure out what that is. So that is going to be 9 centimeters, and on this side, that is going to be 37 centimeters. And that is our final answer. This is a good place to pause the video, and go ahead and do 4, 5, and 6 now, and we'll check your answers when you get back. All right, hopefully you were able to get the correct answers for these. Number 3 and 4 were the only ones where I asked you to put units. 5 and 6, I actually didn't bother to put units on there. But on the SOL exam, actually, they quite frequently have these types of questions. Just pay attention to whether or not there's units for those particular ones or not. Okay, and finally, the last page of part 1 is you're given 3 sides and say, can these 3 sides actually make the 3 sides of a triangle? Now, this is actually pretty easy to do. All you have to do, and I'm over here on the right-hand side, you have to add the 2 smaller numbers together and check and see if their sum is greater than the biggest number. So we represent this like this: A plus B must be bigger than C, and C represents the longest side of the triangle always. So your first step is always to figure out what is your C, what's the longest side of a triangle. Then we're going to add together the other 2 sides and check to make sure it's greater than that. So example number 7 over here, we have 3, 4, and 7. So step 1 is, can you figure out which side is your C? And of course here, our C should be 7. That is the longest side. So that's my C, so I'm going to add together the other 2 sides, which are 3 and 4. So the question is going to be, is 3 plus 4 greater than 7? And of course, you guys know that 3 plus 4 is 7, so no, 7 is not greater than 7. So no, these 3 sides cannot actually make a triangle. Next one, we have 12, 2, and 9, so which is our C? 12 is going to be our C. So we're going to check, all right, that's my C, so add together the other 2, so 2 and 9. So does 2 plus 9, is that bigger than 12? 2 plus 9 is 11, and 11, as you guys know, is not going to be greater than 12. So no, this does not make a triangle either. And finally, number 9. We have 5, 12, and 10. The largest side in this case is going to be 12, so that's going to be my C. So my other 2 numbers are 5 and 10. So I need to add those 2 numbers together and check to see if it's greater than 12. So 5 and 10, I'm pretty sure you guys already know. But 5 and 10 is going to definitely be greater than 12. If I can get my object transparency to work correctly. So 5 and 10 is larger than 12, and we know that my computer's not working correctly. That 15 is greater than 12. So yes, in this case, we actually do have a case where the 3 sides could actually make a triangle. So of these, number 9 was the only one where the other 2 sides had a sum greater than C, and those are the only ones that actually make a triangle. Alrighty, so a couple practice problems here. Can these make a triangle? Answer yes or no. So all of these, you should figure out what is your C first, and then go ahead and figure out what it is. So go ahead and pause the video and work out these examples, and we'll check your answers when you get back. So hopefully your work looked like this. You do need to show work when you do these in order to get credit on a quiz or a test. So don't forget to identify your C so that you know which sides you're adding together to double check. But your answer should look something like this. Alrighty, last one on this video. Go ahead and pause the video, do these last 3 on your own, and then we'll check your answers and we'll move on to part 2. All right, hopefully you got these correct. If you're having trouble with any of these, again, you might want to rewind the video and go back and review those sections. Otherwise, you're doing pretty good. So this video is coming to an end. Go ahead and join me on the second video for part 2 of this lesson.